Okay, so welcome to this video 3.6 where we're going to be talking about expanding brackets. So this is probably one of the newer maybe things that you've had to do in algebra. Again, it's reasonably simple. There'll be plenty of opportunities for you to be able to practice it. And again, it's just another tool that you sort of put in your toolbox, tool bag of things that you can do using algebra. So, in mathematics, these things called brackets are used to communicate an expression in a different format. Okay, for example, this thing here, 5 times a plus 3 is equal to, or the same as, 5a plus 15. We'll see why later on, so don't worry about it just for now. Okay, so you need to remember a couple of things just quickly, that in between here, remember there is a multiplication sign just in there, right, between the 5 and the brackets there. Remember in algebra, if there's no operator, we kind of assume that there is a multiplication sign. So, to expand or simplify an expression with brackets, we use a technique that we'll look at later called the distributive law. Okay, so that's a term for you to remember. Right, first we'll investigate the distributive law using areas of rectangles. This is sort of a graphic way, a graphic or visual way to have a look at it. Okay, so let's just imagine we've got this sort of rectangle shape here. It's divided into two different pieces. We're going to call this part piece A and this part piece B. And let's just say that this length here is 6 and 3, and maybe this one's 12. Let's make this a little easier for myself, 7. Okay, 6, 3, and 7. Little unbelievable. Might make it a bit more friendly. 4. We'll see how that goes. Okay, so I have this shape here, and these are these lengths here. Obviously, this here is 3, and this is 7, 2, and this is also 4. Okay, when we're talking about distributive law, we're sort of thinking about areas. Okay, areas of shapes. And for instance, if you're wanting to find the area of this large rectangle here, there's a couple of ways we could go about it. The first way we could do it is that the area is equal to the area of A plus the area of B. Okay, so we know the area of A is some length times width, and area of B is, again, some other type of length. So we'll put these in little letters, length times width. Okay, so the area of A, we have a look up here, well, it's 4 times 3. 4 times 3 plus the area of B, which is 4 times 7. So 4 times 3 is 12, plus 4 times 7 is 28. And when we add those together, we're going to get 40. Okay? However, there's another way we could do it, that we'd have the area is equal to the area of the big part. So maybe a big L times a big W. So this would be our big length, and this whole length here would be our big width. Okay? So this time we will have 4 times 3 plus 7. Okay, so the length of this part here is 3 plus 7. We can't just put 4 times 3 plus 7 because our order of operations would get us to do this 4 times 3 first. So we need to put some brackets around here to say to add those up first. So if we look at this, so that'll be 4 times 10, which is 40. Great. So what this means is that, therefore, 4 times 3 plus 4 times 7 is the same as 4 times 3 plus 7. Okay, those two expressions are equivalent. Okay, this one here, and this one here, they are exactly the same as each other. Okay, right, we're going to do a rectangle now, and we're going to add a variable measurement in there for a moment. Now don't get too worried about this. We're going to say that this side length here is 5. We're going to call this side length here 7. And we're going to call this side length here x. Okay, we don't know what it is, or maybe it's one that changes over time. It doesn't really matter, it's just some number that we don't know. But we can still figure out the area of this shape. So let's again call this area A and call this one here area B. So what we'll do is that the area of this rectangle, as we knew before, can be calculated by the area of A plus the area of B. And our area of A is the length times the width, which is 5 times 7, plus the area of B, which is the length times the width, so 5 times x, which is equal to 5 times 7 is 35, plus 5x. Okay, or we could rewrite it as 5x plus 35. It doesn't really matter. Okay, right, but another way that we can look at this is by thinking about the area of the entire shape. So we can get the area is equal to big L times big W. So if this was our big L and this side here was our big width that we're using, that means that our length is 5 times the length of this whole piece here is 7 plus this bit here, which is x, okay? So that means that we have 5 times. Remember that we need to put this in brackets because they need to be added before they're multiplied on with the 5. So 5 times 7 plus x, which is, we're going to get rid of this little multiplication sign here and just have 5 times 7 plus x. Okay? So this means, as it did before, that therefore 5, I might rewrite it with our 35 at the start. 35 plus 5x is the same as 5 times 7 plus x. Okay? So those two things are the same as each other, okay? As we said before, this expression here is exactly the same as this expression here. We just use this idea of areas to sort of prove that to ourselves, okay? Right, a couple of things that we need to know. Expanding a set of brackets is going to give us an equivalent expression. Remember that we spoke about those earlier on, a few videos ago. And we expand a set of brackets by multiplying each term inside the brackets by the term at the front of the brackets. And the important part is this, each term, okay? Each term gets multiplied. So we expand a set of brackets by multiplying each term inside the brackets by the term at the front. So for example, 4 times 3 plus x, to carry that out, this is going to be equal to 4 times each of the terms inside. So 4 times 3 plus 4 times x. So 4 times 3 is 12 and 4 times x is 4x. And we are done. Okay, once you get to this stage, you're done. Leave it alone. Don't try and simplify that any further. No like terms. Just leave it. Okay, and so in essence, you are doing this thing. You are distributing the outside term into each term inside the brackets. Okay, you'll sort of see that work a little bit better as we go through. Okay, so there's two ways I'm going to show you to set these out, and I'm quite happy for you to do either. It doesn't really matter for me. Okay, right. So a couple of worked examples. You often might be asked to expand expressions that look like this. So we have 8 times 3p plus d. Okay, it might look scary and terrifying to you right now, but that's fine. We'll work on it. Right, so I'm going to rewrite a little larger for myself. So 8 times 3p plus d. Okay, now, sort of the way I want you to think about it is we're going to draw these sort of claws or arrows. They'll turn into crab claws later on, don't worry about that. But for now, we're going to have 8 times this term and 8 times this term. So if you need to draw these arrows in at the start to remember that, then that's fine. Okay, please do, please do. So this is equal to 8 times our first term, 8 times 3p plus 8 times d. Okay, And so 8 times 3 is 24. So you have 24p plus 8d. Okay, and we're done. Right, that's all it means to simplify these brackets and expand them and distribute it. All it is we're getting our term out the front and we're multiplying it into each of the ones inside. Okay, now I'm going to show the other way to set it out. That's sort of the more normal, simplest, quickest way to do it. Another way to do it to make sure that you don't forget anything, could be a good way to do it at the start for you, is if we have our 8 3p plus d, you can set it up below it. So our plus sign stays, and we still put our arrows in. So 8 times 3p is 8 times 3p plus 8 times d, and you still end up with 24p plus 8d. Now, neither of these are right or wrong way to do it, but I mean, I think that this one here is probably the more correct way to do it. But this here will help you to be able to expand these things at the start when maybe you haven't had a lot of experience, okay? Sort of going down to make sure, because you got to make sure that if there are two terms in here to start with, okay? So we had a term here and a term here, that needs to sort of continue down. You'll end up with two terms in the end when you've expanded some brackets, okay? Right, I'm aware that the video is getting on a little bit, so I'm going to go through these extra examples fairly quickly. Okay, so we have z times 2z minus 3v. Okay, now we draw our arrows to say that multiplies there and that multiplies there. So we carry out this first one. So we have z times 2z minus z times 3v. Okay, z times 2z is 2 times z times z. There's a reason why I'm writing that. And minus 3z times 3v is 3vz. Okay, now remember, when we have z times z, we rewrite that as 2z squared minus 3vz. Okay, and we're done. We can't subtract them. They are unlike terms, and we just leave it alone. Okay? Right. This one here, I have sort of drawn it so that there will be a bit of simplification to come at the end. So 3t times 2t plus 5 minus 10t. Okay, so this is equal to, we draw our arrows to remind us about our distribution. Okay, and so we have 3t times 2t, 3t times 2t, plus, see our plus comes straight down, 3t times 5 minus 10t. Okay, then we carry out these multiplications. So remember, numbers times against numbers, so 3 times 2 is 6, and because this is times, t times t is t squared. Okay, plus 3 times 5 is 15t. Okay, minus 10t. So when we get to this stage, we can see that these two here are like terms, so we can carry out the subtraction, and we end up with 6t squared. 15 minus 10 is 5 plus 5t, and we are done. Okay? Alright, finally, this one is deliberately a little bit interesting, so expand and then simplify this one here. So I have negative 2 times 5m minus 4 plus 3 times 2m minus 2. Right, so we have two sets of distributions to do here, but that's not any more difficult, it's just more work. So we draw our little distribution arrows in, and it's going to be equal to negative 2 times 5m take negative 2 times 4. Now the reason I put that in the brackets there is I don't want to get these confused or mixed up. I want to know that this is subtracting negative numbers, plus 3 times 2m take 3 times 2. Okay, so big long one here, but there's nothing difficult here, it was just a little longer. So negative 2 times 5 is negative 10m take negative 2 times 4 is negative 8 plus 3 times 2 is 6m. Take 3 times 2 is 6. So now that we've got this on here, we're going to collect our like terms, which means to move our like terms around to make sure that they're near each other. So remembering that this subtraction belongs here and this subtraction belongs here, okay? And same with the subtraction belongs to the 6. So we're going to bring the 6m over here near the negative 10. So we have negative 10m plus 6m. Take negative 8, take 6. Negative 10 plus 6 is negative 4m. Minusing a negative number makes it positive, so that means that we have plus 8 minus 6. And finally, we end up with negative 4m plus 2. 8 minus 6 is 2. Okay, thank you for watching all that. I know it's been very, very long, this video, but we'll have plenty of time to try this out in class. Please remember that, again, this is just a tool that you'll use. You're not going to always see the same distributions happening, but I really believe it's something that you can get a hold of and be able to smash through and use to great effect later on. Okay, thank you so much for watching, and make sure you bring any concerns to our next lesson.